Okay, so we are talking about this DFAC, and this is in hexa, and you want it to be octal, right? So if we go into the octal, we have 1 second, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, right? And since it's a hex going to octal, so we're gonna use this trick of the log 8s 16s, right? So we're gonna be log 16s 8, gonna be 2-digit, right? So it should be here 0, 0, 1, 0, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, right? Okay, let's go into the D is 15, right? And F is 17, 15, 17, then A is 12, C is 14, and this is actually what? Octal, right?
Okay, can you try and do it like going through decimal first? Like converting the hexa to decimal and then the decimal.
Do you want to take this to decimal?
No, the hexa to decimal and then the decimal to octal. Can you try to do that?
Yeah, with different example, yeah, I can do this, yes. I can actually repeat the whole entire lecture. I don't have any problem. The most important thing for me that you guys understand what I'm saying. That's it. So let's go ahead from the scratch, right? If you try to move from system to the system, you have to divide by the other system if you are integer, right? So if you are decimal, you are moving to binary. So you have to, and this is actually integer, right? So, you can keep pushing dividing by 2, right? Let's say that, I'm hexa and I'm going to octal, right? So whatever I will divide by 8. If it's fraction, I will multiply by whatever it is, right? So if it's fraction, I will divide by what? I multiply by 2. If it's, going to octal, I will multiply by 8 and so on, right? Let's make a new example, which is basically what? 1, 4, 8, 2, 3. And this is represented in what? In the decimal. And I want this to be what? Octal, right? I want this to be what? Octal. What should I do from your point of view? I will divide by what? By 8, because I don't have any fraction here, right? Do you agree? So
yes.
Yeah, so I would say 1, 4, 8, 2, 3 divided by 8 is equal. So let's take this number. 1, 4, 8, 2, 3 divided by 8. So gonna be something, right? So 1, 4, 8, 2, 3 divided by 8. So it's gonna be 1852.875, right? What is this based on the something per 8? It's what, 78? 7 divided by 8. It's yes, it is 78. So basically this.
Yeah, I think he's having connection issues.
Man's gone. He dipped. Did you guys happen to see?
Can you hear me? Hello? Hello?
Yeah, I saw it. Yes, sir.
Now can you hear me, right?
Yes.
I don't know what happened with internet. They said your internet connection is unstable. Sorry. Anyway, university internet is not stable. Anyway, so this one is actually what is basically 78 plus 1852. Do you agree? Now I'm gonna take this value, which is the quotient, and I will divide it by 8 also, right? So gonna be what? 1852 divided by 8. What the value will be? Let's see.
It's gone again.
You cannot hear me? Hello?
Oh, we can.
You hear me, right?
Yeah.
It's choppy.
1852 divided by 8. So gonna be 231.5, right? Make sense? So this is what? This is basically equivalent to what? 4 divided by 8 plus 231, right? Sorry that I'm asking a lot. Do you hear me? Because I don't want you guys to miss anything. So gonna be here what? 231 divided by 8. So 231 divided by 8 is gonna be 28 plus the 7th 8.
Sorry, Professor, isn't that supposed to be 58 plus 231?
Which one? Which one?
The row above. It says 448, right? Plus 231, but isn't it supposed to be 5 divided by 8?
It's 0.5, so it's a half. So you do 4
This
over
is
8.
half,
Gotcha.
That's point
Sorry,
half.
got it.
right? And we said the general rule that it has to be something divided by the base, right? So the base is 8. So you have to say something divided by 8, it gives you half. So gonna be 4 divided by 8, right? Anyway, should I continue? So now we already have 28. 28 divided by 8. What is the value will be? 28 divided by 8. So gonna be 3.5, right? 3.5 is what? Is basically 4 8 plus 3, right? Now, 3 divided by 8 is what? Is 3 divided by 8 plus 0, right? We are done. Now we're gonna start building our number, right? So what is our number is? It's the following. I will just go up from here. Up is 7, 4. We said 7, 4, and then we said here 7, and here is 4, and here 3. That makes sense? Hello? Hello? Can you hear me, guys? Hello? Hello?
Yikes. And yes, Sam, I did see
Can you
your
hear me
GitHub.
now?
Yes.
Yes.
What the heck was this internet? Anyway,
Where my question was, okay, there's more. There's more up top.
Sorry, can you go a little bit higher, Professor? Sorry.
let's do it again. Let's do it again. Since
Okay.
it went off and went off, it's ridiculous, right? Let's take the number again. The number was this, right? 14,823, right? 14,
Oh,
That's the number.
oh. I
don't know
thought
where
it was 1,852.
That
Yeah, that's what I
wasn't
thought
10.
too.
No, that wasn't 10. The internet now is stable, right?
I think
was,
so, yeah.
I want it to be what? Octal, right? So again, there is no problem. 14823 divided by 8, it should be what? It should be 8 something plus something, right?
Yeah, 7 divided by 8.
So it's gonna be here 7 and something here. What is this something here? I don't remember. So I'm gonna just use my calculator again. 14823 divided by 8. So it should be 1,852 plus 78, right? Now 1852 divided by 8. What is the value will be? It should be also something a plus. So let's see, what is this? So gonna be 1852 divided by 8. So the value is gonna be what? 231 and half. And this half, it means what? 4 divided by 8. If you divide 4 by 8, it will give you half, right? Now you take 2, 3, 1 divided by 8. It should be something 8 plus something. So I take 2, 3, 1 divided by 8. So it should be 28 and 7th, right? Then, I take my 28 divided by 8. The value will be also 8 something plus something. So gonna be 28 divided by 8. So gonna be 3 and half. Half is what? 4th 8. Now the last iteration, right? 3 divided by 8. Yes. So the number now is lower than 8, right? So in that case, I can just say this is 3, 8, and there is nothing here. This is actually the point telling us, stop. No more. Right? Now it's the time to collect the equivalency, right? So where are we gonna collect it? I'll just go back like this. This is what? 7. I will put it where? Lowest, right? We continue. This is what? 4. And this is what? 7. This is what? 4. This is what? 3. So this number, it's equivalent in the octal life to what? To the value in the decimal life. Sounds good? Whatever I shared with you about hexa, octal, whatever binary, this is something a kind of like a simplification, because all of them belong to 2, right? I mean 8 divided by 2, it's give you a value integer, right? 16 divided by 8, it give you even number. 16 divided by 2 give you something, so you can regroup stuff. But general rules, when you are in the decimal, you are moving to something else, you divide.
Is this decimal to hexa?
This is whatever I made in front of you. It's a decimal to octal.
Oh, okay, sorry, yeah.
Make sense? So if you want this to hexa, what you gonna do? You divide by 16. Or you will make a binary and you regroup. Right? So let's do the binary. Just one more, right? I'm not gonna do the fraction because you understand the fraction. Fraction, you just multiply by the base. It's the reverse thing, right? So, excuse me. So now, let's say that, I have 385, 2. This is a value, and this is actually a decimal value, right? This value, I would like to convert it to binary, right? What should I do from your point of view? I will do the same practice I did in front of you. I will divide by 2, right? So gonna be 3,852 divided by 2. It should be something like that. So it's gonna be 302 divided by 2. So you're talking about 1926, and here I have 0. Then I will take 1926 divided by 2. So it should be like that. So it should be divided by 2. So it should be 963 and 0 here. Then I take 963 divided by 2. So now we're going to give me a fraction. So it's going to be 1 over 2, and there is 481. Then, 481 divided by 2, it will give me 481 divided by 2. So it should give me the half I'm looking for, and 240. Then I take 240 divided by 2. That should be give me 120 plus 0 over 2. Then, 120 over 2. So you are talking about 60 and nothing here. Then, I take 60 divided by 2. They're going to be 30 and nothing there. Then, I can continue, right? So, 30 divided by 2, 15 and nothing here. Now 15 divided by 2 is gonna be what? 7.5. So you're talking about half plus 7. If you take 7 divided by 2, it's gonna be 3.5. And then, if you take 3 divided by 2, it's going to be also 1.5. Now, the moment 1 divided by 2, the value here lower than this value, right? Yes, it's going to give me a fraction and nothing as a quotient. So it's going to be what? It's going to be half plus 0. This 0 telling me no more. That makes sense? Now, I'm start collecting my info here, right? So I have here 0. I have here 0. I have here 1. I have here 1. And I have here 0. And I have here 0. And I have here more 0. And I have here more 0. And I have here 1 and 1. So 1, 1. Then I have here 1 and 1 at the end. So whatever in front of me now, it's the equivalency of this decimal in a binary. That makes sense? So imagine somebody's telling you, you are in the binary, and I want you to go into hexa or octal. You don't need to go to decimal. Then you will divide it to octal, right? You understand what I'm saying? Like there is a question can tell you that, convert this to hexa. What you gonna do? There is one way, which is basically you will take these values with this 2 power 0 thing, that 2 power 1, 2 power 2, 2 power 3, yada, 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 up to 2 power n, right? And then you will multiply with the weight and you collect them together, you get the decimal. Then you will start dividing by the 8s or 16s, right? That's actually taken some time, right? So the way to do it is to say that, okay, this is a binary, and this guy is asking for octal, right? Octal and binary. So here is the equation. You just say octal log, right? To what? It's a binary. I need to go to what? Octal. So in that case, 3. So 3 digit of the binary can be taken and replaced by 1 digit of the octal, right? So I can just go here and say, perfect. I have those 3. This is a group of digits can be represented in octal, right? So that will be what? That will be here 2 power 0, 2 power 1, 2 power 2, 4. Then the second 3 digit will be represented in a digit in the octal. So now we're going to be 2 power 0, going to be 1. Then the third digit in the octal is taken 3 here. So that's actually 4. Then, the fourth is going to be those guys consecutively. So that's actually 7. So what I have now is the representation from binary to octal. I didn't need to go back to decimal and, divide by octal and all of these things. It's a mathematics thing. So maybe one of the phrases can come into the exam as the following: convert the following binary number to octal number without going to decimal. I can say that, right? Then you know what is the right way to solve this problem is this way, right? Let's say that, we are into the learning phase. We are not like, Dr. Ali know that this number, the other fast, right? I can just make a little table in the side helping me what is what, and I start moving into it. Do you want me to make the table in front of you? I can make it, it's no problem. So how, the optimum way to do it is like this, right? You just go make a table like this, and this octal, this is binary, right? Octal, how many elements inside the octal system? 0 to 7, right? So here is basically my 0, my 1, and 2, and 3, and 4, 5, 6, 7. I know each one is 3 digits, right? So I can just make it here 3. Let me tell you a trick. In the digits, there is a way for you to fill this table fast without wasting your time. How are you gonna do this? Look at this. Look at this trick. This is actually power of 2 0, 2 1, 2 2, right? Look, this is 2 power 0, right? 2 power 0 is what? 1. right? So that means distance between neighbors are 1. Look at this. What does it mean? This is 0, right? The second 1, the third 0, the 1, 0, 1, 0, 1. Distance between those guys is what? 1. This is 2 power 1. 2 power 1 is what? 2, right? So that means every 2 numbers should be identical. So that means 0, 0. The second row will be 1, 1, 0, 0, 1, 1. This is what? 2 power what? 2. What does it mean? 4. So the fourth number will be identical. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I made a mistake, right? So gonna be
It should be 1, 1, 1. Yeah.
Exactly. So I filled the table in front of you without what wasting time and thinking about something. The only thing I thought about it is those tricks, right? Little things. Now I have this table in front of me. What I need to do, I will take the thing that I gave it to here, right? And I will start looking at the table. Oh, 1, 0, 0. What is the equivalent? And so on.
Can I see the table one more time?
Yeah, let me take. I don't know how can I take a copy of this. Let me see. Yeah, there is a way to do it, you know. I love this tablet, you know. Okay. Now the table is close to what? To the number we want, right? Huh. I just need to group, right? So this is my group. Oh, no, sorry. This is my group, right? I see this 1, 0, 0. I go to the table, 1, 0, 0. Oh, this is 4. You know, I see there this number. Oh, 0, 0, 1. Oh, 0, 0, 1. This number, 1. I see this number, 1, 0, 0. 1, 0, 0. This is 4. I see this number, 1, 1, 1. 1, 1, 1. Oh, 7. I built the equivalent. Any questions so far?
Is there a similar table where you can do with 16 instead? Like
Sure.
tips?
Let's do the table for 16. I made it before, but I will do it again. It's no problem. Look.
Is there any tips for that one too? Because for this one, you kind of
Yeah,
like,
let me make another example for you for hexa. Same
okay.
thing for hexa. What do you think? So for hexa, we have how many number? It's a hexa. That means 16 base. So that means 16 minus 1. So that means I have 0 to 15. Right? So you look like this and say hexa, and here is the binary. Right? So I'm expecting this table will have a 16 row. Right? So what is this row are? Basically 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 16. Just make it 10 for now. Okay, 10. 11, 12, 13, 14, 15, right? 0 to 15 are 16 numbers, right? Now, there is nothing called 10 in hexa. So what I'm gonna do, I'm gonna just change the color here in front of you, and I make it what? This is represented to be A. This is to be B. This is to be C. This is to be D. This is to be E. This is to be F. Sounds good? Now, I need to see what's the number of the logic thing, right? I'm in binary, I'm going into hexa, right? So that means I'm in a binary hexa 4. So that means I should expect every single representation in the binary to be 4-digit. So 1, 2, 3, 4, 2 power 0, 2 power 1, 2 power 2, 2 power 3, right? So first one we said what? 0, 1. The other one, 2 power 1, how many it will be? The other one, 2 power 2, so that means gonna be 4. The last one, 2 power 3, should be 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So now I already have the table filled in front of you, right? So what is now the trick? The trick will be the following. I will look to this number in front of you. This is the number, right? Let's take this number somewhere here again. So it's gonna be 0, 0, 1, 1, 0, 0, 0, 0, 1, 2. Is this 1 also? 1, 2, 3, 4, 5. Something like that, right? And this is a binary. I'm asking you to convert this to what? To the hexa, right? Now we're gonna group what? How many digits?
4.
Huh?
4.
4, yes. So this is 4. This is what? This is basically here in the table C. C. And 1, 2, 3, 4. So this is another number. So this is what? 1. 1, 2, 3, 4. This is from the table, this one, E. Then this is just 2, right? You can add infinity zeros if you want, right? Nobody will touch you. Basically, number will be nothing. So 0, 0. So here number like this, 1, 1, 1, 0. So that's basically 3. So this number in front of you in the binary equivalency here is gonna be what in hex?
Wait, Professor, isn't it supposed to be C0F? Wait, what number
Yes,
is this?
I made a mistake. You are right. Where's the mistake? This one,
Yeah, the second one.
right?
Oh, got it.
Good that somebody got the problem. Yes, I told you last time that I make mistakes. So here we 1, 1, 2, 3. Oh, scheiße. 0, 1, 2, 3, 4. So you can clear up this much faster, right? Okay. So this is C. 1, 2, 3, 4. This is 0. 1, 2, 3, 4. This is F. This one with 3 zeros is gonna be what?
1. Yeah.
1. So this is actually the correct number. But thank you that somebody's actually following. That's perfect. Any questions so far?
I have a question. So you have to start from the right to the left, because if you start from the left to the right, you'd get a different answer, correct?
Not really. Let's try. Oh yeah, that's correct. Yes. You have to start from the lowest to the highest.
Okay, and then I also have a question about the logs. I think on when it was the hex to octal, you said it was 2 bits, but when I did the logs, it was like 1 point something. Do we just assume it's 2 or
That's
close?
why it's go to.
Okay.
Because you make it what? You mean like this, right? Log 8, 16. You know how to do in the calculated log 8, right?
Yeah, yeah.
It's log 10 over log 8, 10. It's like this. It's basically log 10, 16 over log 10, 8. Make sense?
Yeah.
Any other questions?
Professor, can you just scroll down a little bit so I can take a screenshot of the other half of the table? Thank you.
This is gonna be shared with you.
Okay.
Wait, can you go up? Can you go up a little? I'm still confused.
Sure.
So wait, how is there an extra 1 there?
Where's that?
on the 1.
Yeah,
This one?
he added an extra one.
Why?
I think it's a different question, or is it supposed to be the same
This is
number?
not the same. It's just like an extra one.
Oh,
number.
okay.
Yeah.
Okay.
Yeah. He just added another one. that's
Yeah,
all.
Just
'cause I
an-
was going back. I was counting. I'm like, there's
No,
no way.
no. Just a number. Just a number. Yes.
So when I do like log base 16 is 8 is 0.75. So what is that supposed to be?
Did you make this one?
Yeah, that's what I did. Yeah, log. Yeah. Oh, let me try that again. Well, I did log 16 8 is 0.75. Okay, let me do that again. Log 10 to 16 gives you 1.2. So you said just do it as 1?
Because you how to say
You wrap around.
yes.
Uh-huh.
Any fraction you see it, you just go up. It doesn't matter what is the weight of the fraction.
Okay, you just go up. Okay.
Okay. Any other questions before we move to the next part?
Professor,
Yes.
I know I've asked this before, but I don't know if you got it. So you know the first example we did, the first exercise with the df.ac. I'm asking, right? Because I did what you just did and I had the answer you had, what we did above. But when I tried to do it by converting the hexal to binary first and then converting it back to octal, it didn't give me the same answer.
It's not reversible thing. You know what I mean?
Oh, okay.
It's not completely reversible thing. It's just a representation, right?
Okay.
The whole idea is representing number. So I'm representing it. But it doesn't need to be the same, you know?
Cool. So it's
If you are
possible
thinking about, I understand what you're saying. If you move to the decimal, everything, you know, if you have to move to the decimal, that's another story. But you're losing precision.
Okay.
Okay?
Okay.
But as I'm saying, let's say somebody's telling you, here is the binary number, right? And it's telling you, I need to see the octal. What are you going to do? Are you going to move from the binary to the decimal? Then you know you will divide by 8. Then you know you return it back to octal. That's a very long step, right? So the best
Yes.
way to do it is actually start regrouping, so you know some resolution will go.
Okay.
Sense?
Professor, can we try a number with a decimal place?
Which number? Tell me.
Say like 143.274.
1,4 what? Wait, 1 second.
Decimal point. 143.324.
3 what? Like this?
Yeah. If we want to do that, that's decimal to binary.
Let's do it to binary. How are we gonna do it? Tell me. 14, we know it, right?
Yeah, 14. We just it's.
We know. I mean, I'm not
what-
gonna repeat it, but you know,
yeah.
let's go for 0.324, right?
0.324
0.324 times 2.
times 2.
What the value?
0.64 or 0.648.
I mean, I'll do it on the calculator first. So anyway, 0.324 times 2. So you're talking about 64. What's the heck? 1 second. 648, right?
Yeah.
How many digits you are looking for? How many precision? What is your precision? 3
Right.
or 4 or 5 or what?
4.
Let's say make 4, right? So that means I'm gonna do this 4 times, right?
Mhm.
So now I'm gonna take this as a fraction and also multiply by 2. So I take the fraction 0.648 times 2. 1 second. 0.648 times 2. It's gonna be 1.296. Oh, I like this number. Okay, leave it now, right? So I'm gonna take this fraction again, the fraction. So it's
Mhm.
gonna be 0.296 times 2. So that's actually 0.296 times 2. You're talking about 0.592, right?
Mhm.
What else we're gonna do? Take the fraction again. We say 4 times, right?
Mhm.
So this is gonna be the fourth for us, 0.5 92 times 2. So they're going to be times 2. It's going to give us 1184. We stop. Right?
Hmm.
How are we going to start collecting? It's going to be from here, 0. So I take the integer came from the operation. So 0,
Mhm.
1, 0, 1, 0, 1.
And then we go the opposite way. Got it. From left to right this time.
Yes, because we know what is the lowest to the highest.
The lowest to highest.
That makes sense?
Mhm.
Same thing you're gonna do with any system from the binary. Let's say multiply by 8. So the
That'd be
value we're
octal.
expecting here before the point is gonna be something between 0 to 7.
Got it.
Easy peasy lemon squeezy.
Sounds great. Thank you.
Super. Any other questions so far?
Switching that into decimal, you'd go left from right, from 2 to 0, from 2 to n number, right? Okay.
Let's do this, right? I would like this to be decimal. What should I do? So before that was 2 power 0. 1 second. Interesting. 2 power 0, 2 power 1, blah, blah, right? Before the decimal point, so you're going to be what? 2 power minus 1, 2 power minus 2, 2 power minus 3, 2 power minus 4. So you're going to make it weighted. So, 2 power minus 1 times 0 plus 2 power minus 2 times 1, and so on and so on. So for instance, this is actually 0.25 for us. That makes sense?
Yes.
Any other questions? My advice, practice. The only problem I have here, we have just 1 hour, 15 minutes, right? If I have more, I swear we'll just practice for practicing of the practicing, The whole idea for me is not just taking a course and having a grade. It's basically for you, this is going to be used for other classes after that. The rest of your career would be using this, especially even if you're a computer engineer. Okay, doke? Now, let me move to the next part of the chapter. So the next part of the chapter is really fun. And what is this fun? We don't subtract in the computer. We add. Have you guys heard about this? What is this? It's based on a mathematics formula. It's called complement. I'm complementing stuff. There are 2 different complements. We have something that's called R minus 1 and R complement. So they call it what? R minus 1's complement or R's complement. What is this R? The R is the base of the system, number system. Example, right? I'm a binary, right? So my base, which is the R, is equal to. So I'm expecting 2 different type of complement of the binary, which is called 1's complement or 2's complement. Make sense? 1's complement, 2's complement. Let's say that, I'm in the decimal, right? I'm decimal. My R is 10. So I'm supposed to have what? 9th complement and 10th complement. I'm in octal, right? My R is 8. So that means I am what? 7th complement or what? 8th complement. What does those guys are? Right? Let's see what does it mean. So if you take it one by one, you think about, let's say you go into the decimal, right? Let's go in the decimal. My decimal 9's complement mean every single digit, maximum value of it is 9. Do you agree? So if I have a number and this number is 54700, which is actually an example in the book, you will find, let's move with an example and then you will move something from problems. And this actually what intents. And I'm looking for the 9's complement of it. What should I do? Regulation will be the following. How many digits I have in front of you? I have 1, 2, 3, 4, 5, 6 digits, right? So to apply the 9's complement, I have to generate 9996 times. So it's gonna be 9, 9, 9, 9, 1, 2, 3, 4, 5, 6. And I subtract this from the number I have in front of me. Somebody will tell me, oh, but you told us there is no subtraction. I will show you what does it mean. Okay, so now we have here 0, 0, 7, 6, 4, 5. Then you will start subtracting. So 9 subtracted, 0 subtracted from 9 is what? 9, 9, here 2, here are 3, here are 5, and here are 4. So the number in front of us is still in the tens, it's a tens system or the decimal system. This is the 9's complement output of this process. So if somebody asks you, how can you apply 9's complement? You will do this for this process. Okay. Later on, I will tell you why we need it. Okay, but at least we understand the mechanism how we do it. Okay. Now, if somebody asking you to do now what is the equivalency of the 9's complement in our what? In our what? Binary is the 1's complement. Right? You remember, right? It's r minus 1, right? So r is what? 2 minus 1, 1's complement. Let's do the 1's complement on a binary number and see what will happen. Okay? Because don't forget, the whole entire computer is just binary. There is nothing called tens or whatever, it's just, this tens thing that, handwritten thing that you do it by your hand. Okay? So now assume a number. Somebody give me a number in a binary. Who would like to give me a number? Gabriel, give me a number.
1 1 0 1 1 1 0.
Like this?
Yeah.
Okay. So this is the number that Gabriel choose, and we're gonna go get what? The 1's complement, which is r minus 1, right? So 1's complement, right? Now in 1's complement, how many digits we have? We have 1, 2, 3, 4, 5, 6, right? So we're gonna do the same trick like we did with 1's, right? So we can have what? 1, 2, 3, 4, 5, 6, right? Subtracted from the 0, 1, 1, 0, 1, 1. You agree? Let's do it. 1 from 0, 1, 0, 0, 1, 0, 0. Have you noticed something? This is the 1's complement, right? Which is look like what? You flip the number. So in the 1's complement, you're just flipping. You don't need to subtract. If somebody give you another number, which is like 1 0 1 1 0 1 1 1 0 1, like this, and I would like to ask you for the 1's complement of this, what are you gonna do? You don't need to do this bunch of ones and you subtract. You just know that it's gonna be what? Flipped, right? So the 1 is gonna be 0. This 1, this is 0. This 1, this is 0 0 0, and this is 1, and this is 0.
Professor, you're never gonna be using negative numbers, right?
I'm gonna show you. You know why this complement is actually happening? Complement helped me actually to prevent negative numbers. We're gonna subtract using it. Just like follow this, okay? So if this number is represented in something called A, the 1's complement of it is A and dash in the top like this. That's called complement, or 1's complement. So 1's complement of A is equivalent to sounds good?
Oh, it's the same thing as not gate.
Yes, I mean you
Right.
know, come on, you know, let's follow the rules so we make
Okay.
it easy for people, you know. Not everybody know what is not gate, right?
Got it.
Okay, anyway, so now you know 1's complement is flipping the entire variable, which is whatever holding numbers, to another form, which is subtracting every single digit by the maximum of it, right? Anyway, there is the 10's complement, right? Let's go to the 10's complement. What is 10's complement? It's actually 9's complement plus 1. Okay? So let's go like this. So 10th complement is equal to the 9th complement plus 1. Okay? 2's complement is equal to the 1's complement plus 1. Soon we're gonna come into why we need it, okay? Did you see what I'm doing now? He's running into a wall, I don't know why. Anyway, what happened? Anyway, so let's go now to the thing of the tens, right? The thing of the tens. Let's go to the example I made it with the tens. Here is the tens. Where is it? Okay, so this value, it was the 9's complement, right? If you add 1 to it, that means you got the 10's complement. Okay, sounds good? I'm gonna make example now and telling you why the 10's complement is important. Okay, so let's have 3, 4, 2, 1. This is a number represented in decimal. And I'm looking for my 10's complement of this. So what I'm gonna do, I will just say that's a 4 digits. So 1, 2, 3, 4. And then, you know, 1, 2, 3, 4, 3 here. And I start subtracting it. So gonna be here 8, 7, 5, 6, right? This is what? The 9's. Then, you know, I will add 1 to the first digit. So it's gonna be what? 9, 7 here, 5, 6. So this is actually my 10's. Sounds good? So we learn now 10's complement. Let's use the 10's complement, right? So there is an equation which is very interesting. What is this equation? If you say B and you convert it to B complement and you add 1 like this is equivalent to subtraction. Again, so if I have A minus B, I cannot do it in the computer. So I have to form it into another way. So that minus B will be converted to the 2's complement if I'm in a binary, 10's complement if I'm in decimals, 8's complement if I'm in octal, and so on. That makes sense? We'll do it. Anyway, so A minus B, it should be written into A plus B like this. So everything turned to be adding. Okay? So let's do some example for this. Okay. If I have 3,250 subtracted from the 72532. Okay. Let's apply this to see whether that will happen or not. So how are we gonna do it? I'm gonna take this one and I make the 10's complement and I go add it to the value there and see what the value will be, right? So in that case, excuse me. So I have here what? It's 72532, right? Oh, National Institute of Justice. Anyway, so gonna be how many? 1, 2, 3, 4, 5. So I have 5 digits. So gonna be 1, 2, 3, 4, 5. This is 2, this is 3, this is 5, this is 2, this is 7. You subtract. So the value is gonna be what? 7. This is 6. Here is 4. Here is 7. And here is 2. Right? This is my 9's. And then I add 1. So they're gonna be 8, 6, 4, 7.2. This is my tens, right? Now I'm gonna take my value of the tens and I put it there. That makes sense? So they're gonna be what? 3, 2, 5, 0. And this number is what? 8, 6, 4, 7, 2. And I add. Before adding, I have to be sure they're aligned. What does it mean, aligned? This is 1, 2, 3, 4, 5 digit, but this is 1, 2, 3, 4 digit. So that means, I can add here 0. This 0 will not affect anything. If I say 0, 3, 2, 5, 0, it's actually 3, 2, 5, 0, right? Let's add it together. So 0 plus 8 is what? 8. 5 plus 6 is what? Is 1. And we have 1 here. So that means 7. 3 plus 7, 0. And then, we have here 3. This is 3, whatever, right? Let's go and do the subtraction and see whether this number would be the same or not. Right? So what was the value? That was, we were subtracting something from something, right? I forgot what was. That was this value, right? So the value it was 0, 3, 2, 5, 0 minus 7, 2, 5, 3, 2. So the value is coming into what? Let me see. This value is still in the tens complement. Okay? But if I do subtractions, let's go there. If I subtract this value, it's gonna be what? 3250 minus 72532. So the value should be minus 69282. Do you guys agree? If you do another tens complement for this, that number will come to you. Okay. Other thing.
Professor,
Yes.
what do you mean by if we do another one? Is it like just adding one, or we have to subtract and then?
You will take it another tens complement of it. You know what I mean? If you have a number, when you do tens complement, what you're gonna do? You will subtract 9999 from the value, and you add 1, right?
Yes.
That will revert it to normal number I need, which is basically -69 whatever.
Okay.
That makes sense? Let's do it. So, okay. So I have here 30718, and I have here 99999. As I subtract here, it's gonna be here 1 8 2 9 6, right? Look, then plus 1, so it's gonna be 28269, right? Is this value is the same like this value? It is the same, but we have negative. How I will know it's a negative, right? The negative came from where? That the value came of this process is positive. That makes sense? So if you notice, the value came here in front of you, 69282, right? Go there, 69282.
You said the negative came from what?
Came from that, the number before the subtraction is actually, I'm sorry. It's higher than the 32952, right? 3250. So basically we have to build a comparator, and the comparator will compare the two values, and from there the sign will be assigned.
Mm-hmm.
You understand what I'm saying?
Yes.
Okay. But at least, because, normal circuit, when we'll come in chapter 2 and chapter 3, you will see how you're going to build a circuit acting like that using the logic gates. But at least, we understand, we made the process, and then, we have to also tens complement in this case so we can get the value, right? Let's do it in the binary. So we try it now in the decimal. decimal theory, but you know, binary is as a computer, right? So let's do it now. So I have somebody give me two numbers in a binary, need to be subtracted. Let's try something simple. So like 1011 subtracted from the 0111. Okay. So now this has to be what? 2's complement, right? So the first story is gonna be 1110. This will be 1's complement, which is basically flipping every single one to be 0 and so on, right? So this one will be 0, 0, 0, and 1. So what I have now is the 1's complement. I add 1. It's gonna be 1, 0, 0, 1, and this is actually my 2's complement, right? I take this and I take this and I start adding them to each other, right? Let's see what will happen. So gonna be 1, 0, 1, 1, plus whatever net come here, gonna be 1, 0, 0, 1. Let's add. So here, 1 plus 1 is what?
1?
0.
Oh.
So that's something I need to teach you, which is basically the following. 0 plus 0 is what? 0. 1 plus 0 is what? 1. 0 plus 1 is what? 1. 1 plus 1 is what? 0, and you have carry. It's like when you said 6 plus 5. What 6 plus 5 is what? 11, right? So you put 1, and there is extra 1 will go to the other digit, right? That 1 will go to the other digit. So let's do it here. 1 plus 1 is 0, and there is 1 will go here. Then you know 1 plus 0 is 1. Then you know 1 plus 0, 1. 1 plus 1, 0, and there is an extra 1 happen here. This extra 1 came to me. It's actually the 5th digit. I don't need it. This is an indication I don't need to make 2's complement. This value is positive. So if you go here, literally, this value is what in the decimal? Somebody can tell me. This is 2 power 0, 2 power 1, 2 power 2, 2 power 3, right? So this value is 2 power 0 is 1. I think this is 1 plus, 4 plus 8.
13.
That's 13. Minus, this is what? 7, right? So 13 minus 7 is what? 6, right? What is this value? That makes sense? So I don't need to make 2's complement to get the output. So back to the question that Leslie asked, right? For this one, right? Why I applied the 10's complement? Because this process didn't give me extra digit. Sorry, not this one. This one. This process didn't give me an extra digit. So what does it mean? It means this value is in a 10's complement and is actually processing negative value. That's why I have to make 10's complement so I can get the value out of it, and then I will put negative here. But if the process give me an extra, that means this value, it is the right value, is a positive. I don't need to make the complement one more time. Is it clear so far?
So you only have to do it one extra time, right?
If it's positive, you don't need to make one more time, right? But if it's negative, it's holding a negative value, you have to do one more time to show me the negativity, right? Here, for instance, let's take it one by one. That's this example, right? This example, if you say 13 minus 7, right? What is the value will come out?
Positive 6.
Sorry, 13 minus 7 is 6, right? You're right. 6 positive.
Positive 6, yeah. Mhm.
Yes. So how I can see this in this complement things, I will go there and I do the flipping as I did, and the value was in front of you like that, and I added to this value. There is extra digit came here with 1. This is an indication this value is representing a positive value.
can we try it with the numbers flipped? 7 minus 13.
Let's try it here. So I have 7 minus 13, right? So I have here what? 1, 1, 0, 1, and I have here 1, 2, 3, 0, right? Let's do this. It's gonna be what? 0, 1, 0, 0 plus 1. So you're talking about 1, 1, 0, 0, right? So I take this, add it to that. Let's do it. So gonna be 1, 1, 1, 0 plus this together. So you are talking about 1 plus 1 is what? 0, 0 is 1. 1 plus 1, 0. And here is 1, there is 1. And there is 1 here, gonna be here what?
0.
0. And there is 1 here, gonna be here 1. Nothing came out of here. So it means this value is still need to be flipped one more time so it can give me the negativity, because this is actually an indication this value of it will do 2's complement, it will be negative. So I take this value 0, 1, 0, 1 and I flip it. So it's gonna be what? 1, 0, 1, 0. I add 1 to it. So 1 plus 1 will be what? 0, 1, 1, 0 and negative. What is this? 6. Make sense? Any question? Jonathan, do you have any question?
Yeah, so in the first example we did, the final answer would be 0, 1, 1, 0.
Which one? Here, this one?
Yeah, right there.
Yes, sir. Okay.
Okay.
What is the question you want?
Oh, the final answer, like in an exam or quiz or whatever, it would be 0, 1, 1, 0.
Yes.
Okay.
If you take 13 minus 7 is 6, right?
Right.
13 is greater than 7. So that means that the output is coming into positive form, right?
Mm-hmm.
But then, if you flip, there is negative will happen. How you can represent this in the 2's complement? The value will come without extra digit. And then from there, you will flip it one more time to present it.
I got you.
That makes sense?
Yeah. Thank you.
We can also try the example of the 7 to whatever, the 69,000. Do you want to try it again? We flip it and see how it looked like. Do you remember when I made it like that? It was like 3250 minus 72532, right? We did this one and I flipped it. Do you guys remember?
Yes.
Let's flip it and see what will happen, right? What do you think? So, if I say 72532, subtract it, and then, 3250. I expect this value will be positive, right? Because this is smaller than this one, right? Let's do it and see if it will give me the answer or not. So, I have here 4 digits, right? So I will take here 0, 5, 2, 3. And then, I have here 0, because it has to be 5 digit, because it's also 5 digit. And here is 99999. Subtracting it. Can you try it now? It's gonna be here 9, 4, 7, 6, 9. Add 1. So gonna be here 0, 5, 7, 6, 9. Right? If I take this value and I add it to this value, what will happen? So gonna be here 2, 3, 5, 2, 7. Let's add it together. So they're gonna be 2, they're gonna be 8, they're gonna be 2, and then here gonna be 9. 9 plus 7 is what? It's gonna be 16. So 6. Here is extra one came out, and this is the value we had before. That one is indication. This is actually the net. I don't need to do any 10's complement to represent the negative. Make sense?
Professor, what did you just say? What was the last sentence you said?
The last sentence. That's an extra digit came out, representing to me that this value in front of me is representing in positive. So I don't need to do 10's complement to return it back to the normal form. Okay. Make sense?
Can you do this with hex?
We can do it with hex. We can do it with anything we want. You know.
So
Let's
how
do
would
it-
you
Let's do
do
it with hex. Let's do it with hex. Let's do it
how would
with
you
hex.
do C minus 3?
It's 12 minus 3. You do it and then you will flip it, right? Let's do it. Let's do it.
Would
Slow.
it be 8 minus C?
Let me just put an example and we'll do it, right? So I have here 3, 8, AB subtracted from the 4B, CA. Right? How are we gonna do it? So I'm gonna do what? The 15th complement, right? What is 15th complement? It's gonna be F, 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 subtracted from the ACB4, right?
Oh, so you do it from the 15th complement. Okay, okay. All right, I messed up.
No, you're fine. Anyway, any questions so far? You have any questions? My whole advice, practice. I'm very slow in this chapter, so at least you can collect more information and you get like a very strong background. Then, you know, once this will be done, we'll start moving a little bit faster.
What chapter would you recommend reviewing in the textbook?
Chapter 1. That's the number system. Okay, so at 100, can we finish solving that one? Sure. Let's do it. So, you know, 15 minus 10 is what? 5. 15 minus 12 is what? 3. Scheiße. 3. 15 minus 11. 4. 15 minus 4 is what? 11. Right? Add 1. So gonna be 6, 3, 4B. Then you will take this together and add them to what? This value. So gonna be here 3, 8, AB added. So we have what? 6 plus 11, right? So gonna be 17, right? Do we have any 17?
Nah.
We don't. We have 15 with 2, right? So we have here the 2 and the 15 will be 1 here. 1 plus 3 is what? 4. 4 plus 10, 14. 14 is E. Then, you know, 4 plus 8 is what? 12. Then, you know, B is what? 11. 11 plus 3 is what? 14. E. There is no extra number. This is need to be inverted. Then you will make another hexa and you'll be done. Any questions? Any concern? So if you guys have any questions, you know, don't hesitate, ask.
So
Any
right now,
question?
we'll do another complement, 15 complement,
You can make 16s,
the 16. Yeah. Mhm.
which is 15 plus 1, you know? And that will be represented in negative after that, right? Any questions? Practical life, people use 2's complement, 1's complement. Nobody do the 16s and hexa, sorry, the 10s and stuff like that. But I'm just telling you the general form and applying in number system, since chapter is number system. But you know, real life, it's just 2's complement and 1's complement.
Professor,
Yes.
when you say extra digit, do you mean anything besides 0 on the left, on that where you circled?
Yeah. Is there any number here? Is there 1 or 2 or 3 or whatever? You know?
Yeah, no. So that means, but if there was one, it would be anything besides 0. That tells
That
me
means
it's
there is an
integer.
extra digit got created
Okay.
because the 0 is not creating a digit.
Yeah, but anything else, yeah.
Yes, sir.
Professor,
Yes.
can you do D minus 3?
What? D minus 3?
Yeah.
Let's do it. So D minus 3, 3, right? Let's go it. So here I have 3. So that means I have to go to the F minus 3, right? 15 minus 3 is what?
Oh, I took the wrong one. Oh, I'm an idiot. Okay. All right. Thank you.
Okay. Any questions? Any other questions? By the way, we are over the time. It's 2:17. I don't want you guys to lose your chance for jumping to the other class. So in that case, I would say thank you guys. It was my pleasure to talk to you today, and I hope that you guys understood something from the class. And if you have any problem, you know my syllabus. I mentioned that you can book like a slot of time during my office hours, and my office hour Monday, Wednesday. And other than that, just send an email, and I will be more than happy to assist you. Okay, guys.
Thank you.
So a copy of the notes, a copy of the presentation will be under the week number 2. Okay, learning unit week number 2. Thanks to you guys. It was my pleasure to talk to you. God bless you. Thank you.
Thank you.
Thank you,
Have a good
Professor.
one.
Professor.
Bye-bye.
Have a good day.
You too, thank you.
Have a good one.
You too, thank you.